Yes, so you want to learn about Bittensor. Bittensor is a decentralized network for creating incentives for decentralized networks. And this is a site called Taustats where you can find a lot of useful information. And we'll be using that to go over the three main actors on the network. We have validators, we have subnet creators, and then we have miners. To give you a brief overview, the subnet creators, they create different rules for networks. Right now there are 32 networks. The validators are in charge of evaluating all the miners of the network. And the miners in turn are the ones that perform the task on the network. Each network have different rules for how the miners should be evaluated. So each validator joins each subnet and then has a task to run the validation code, which are basically which is given to them by the subnet creator, and that way they evaluate the miners and all the miners can get score. Yes. Right now there are 32 subnets, and not all of them have emission, but the emission is decided by the validators. So the validators, as you can see, they have different amounts of tau, and the more tau they have, the more impact they have on how emission shall be distributed among the networks. So what is emission? Well, every day 7,200 tau is created, and those tau are distributed between the networks and goes to the validators, the miners, and the subnet creators. To create a fair way of distributing this tau between the different networks, the validators, they vote. For example, this biggest validator, it says, 8% should go to subnet 1, 3% should go to subnet 2, and so on. And then all of these votes are put together, and you can see that the consensus vote for subnet 1 is 6.95%, subnet 2 is 1.65%, and so on all the way till subnet 32. The consensus algorithm is a sort of UMA consensus. It means that it should be pretty reliant to if a few validators, a minority of validators, vote very strangely. That shouldn't impact too much. So it gives it a sort of resilience to one or two validators having very different votes than the rest. So I thought we could look at an example subnet and see what it does. If we go here to the subnets, we can see that most of them have different names. Some of them are still unknown or not registered. But we'll look at the first one, which is for text prompting. This is the oldest subnet, and the purpose of it is to incentivize having very, very smart text models. As you can see, there's about 27 active validators. You can see that they have a few thousand stake, and then there are just these small ones that probably aren't validating. As you can see, they don't have any vtrust, which means they're not validating. We'll go over the columns one by one, but first I can just go over how the network overall works. And see if you have any questions, you can just write it in the chat. So the network works like this: that validators, they send requests to the miners. You can see that the miners have different UIDs, and then the miners, they return a reply to the text, and the validator scores it. The rules for this can vary greatly between the networks. In the case of subnet 1, they send text requests, a text prompt, and then the miner returns a text generated by AI. Actually, I think it might be multiple text in some cases that are sent, because they have a very advanced algorithm for actually generating these questions. The validator then runs a scoring script that gives each miner a score. Then, when every interval it's called, the validators, they basically vote how good is each miner. It gives them a ranking basically, and this determines the incentive of the miner. The incentive is basically their score, where the higher the score, the better the miner is according to the network, and that means that they also receive a higher reward in the form of tau. So we can see that the top one receives 0.25 tau per day, and as we scroll down, they receive a little bit less. So let's go over the columns one by one. The first one is UID. On this specific network, there is 1024 UIDs, and they are just a unique identifier for each miner or validator. The most network, they have 256 UIDs, so subnet 1 is a bit unique in that regard. Second column is the stake. That's how much tau each validator have, and as I said before, the more tau they have, the more impact on them incentive miners should get they have. So this one has very much impact, and these have very little impact. We can look at vtrust, and that basically means how much does this validator agree with the consensus of the other validators. It's basically a metric of how similar does this validator vote compared to other validators. This one has 93%, which is, well, it's quite similar, but not completely identical. The second validator is much more in consensus with how the other validators vote. So this one pretty much takes a more similar weights to the average consensus of all the other validators. This one has quite low, 89%. It's still not that low, but it might be because it has some older version that it's running, or it has some technical problem, and that would cause the validator to vote differently for some reason, and that could cause it to get lower vtrust since it would be voting differently. Let's move over to emission. This is how much tau they get. It's a metric. Here we can see the actual daily metric they get, but this is something like how much tau they get per interval, I believe. So we can see the daily reward here, and for the validators, the daily reward they get is proportional to their stake. Updated. It's only relevant for validators on most networks. It basically means how long time has gone since they last set weights. And what do I mean by this? Well, setting weights means that the validator says, oh, I think miners should be ranked like this, and they push it to the blockchain, so it can be compared with all other validators' votes. They can do this often or seldom, and in this case it was 46 blocks since it last did it. Each block is 12 seconds, so it's about 500 seconds or 8 minutes since it last set weights. If something would be wrong with a validator, it might set weights less often. Like if the server crashes, it might not set weights, and that means that it wouldn't be updating the scores for miners properly. That could again cause it to get lower vtrust because it would be using older scores while everyone else keep updating. For miners, you can mostly ignore this because as a miner, you don't really vote. You don't have any impact when you vote and set weights. However, some subnets may have used this function to see that miners are running actively and might make validators blacklist them if they don't have a low updated number. But most subnets do not have any such function. The axon is the IP address on which the validator or the miner is running. On many networks, validators can actually hide their IP address, but miners generally have to share them so that validators know where to send their requests. Then we have hotkeys and cold keys. Basically, when you want to create a miner or a validator, you first need to create a cold key, which is an address. You can store tau here, and you can register multiple hotkeys on a cold key. The hotkey then you can register on a network or multiple networks even, and you pay a bit of tau for that. Let's then have a look at the columns for miners. We've already talked about the incentive column, which is the most important for miners. It's basically how well do you score, and you can compare it with other miners. So why is this important? Well, it's important for two reasons. One, the more incentive you have, the more tau you earn. And two, every day miners are recycled. That means that the ones with the lowest incentive are kicked out, and new miners enter in their place. So if you have a very low incentive, you can lose the miner and you have to pay to register again. Registration costs vary from network to network and over time. So you can see that here the registration cost was 0.45 tau. Here it dropped down to 0.11, then it went back up again. So to register, you pay a certain amount of time, you get 24 hours of immunity, and every time you register, the current miner with the lowest incentive gets kicked out. The 24 hours of immunity is there because it takes some time usually to build incentive. You first have to start up the miner and so on. The validators have to query you and score the responses. So that's why you have the immunity. Probably if you want to bind, should create an automatic registration script that you set the price for, because sometimes it can be very difficult to time these low price points. So an automatic script, you can find that in Tensor Teacher GitHub, or you can build one yourself pretty easily. But there is one existing that you can use to have to do that yourself. Just like the validator, we have hotkey, cold key, we have an axon, and you can see here that the updated number is oftentimes very big because they don't have a reason to set weights on the chain. So that is a basic overview of subnet 1. I thought we could look at another subnet to go over a little bit more detail. And if anyone has any questions, feel free to write in the chat, and we will go over that. So next subnet we will look at is subnet 23. It is in some sense more like a more common subnet, because most of the subnets will share the same hyperparameters as it. Hyperparameter means basically settings for the network. As you can, so this network, it has 256 miners active on it. Also 256 UIDs, of which a few are validators, 19 are validators, and the rest of them are miners. To have a validator, you actually need a minimum of 4,000 tau, and that also gives you immunity. So even if you have zero incentive, if you have 4,000 tau, you will not get kicked out of any network. And validators, they have the same hotkey and cold key on all the subnets. So therefore, to maximize your reward as a validator, you really want to be active on all subnets. Most people therefore choose to delegate their stake. So they pick a validator they think is doing a good job, and they stake their tau with them, and in return get reward. The validators that they stake with, they get 18% of the income reward, and the other 82% goes to the owner of the tau that is staking with them. Another thing that can be worth mentioning is that this daily reward is dependent on the v-trust as well of the validator, meaning that if any validator would, for some reason, set much higher weights on their own miners or their friends' miners, they will get lower v-trust. This one's very low v-trust, and that leads to them having less rewards. And this one having lower v-trust, it's probably nothing malicious. It's probably just that they haven't updated most recently, or maybe their server crashed or something. It happens all the time. And usually you just fix back up and your v-trust goes up in 1 or 2 hours. So we can also have a look on the registration table and explain what intervals are. So time is measured in blocks in the Bittensor world, and each block is 12 seconds. And in one block, you can only do one thing with your hotkeys. For example, if you want to send tau somewhere, you can only send tau from one cold key to another one time per block. If you have multiple cold keys, you can send from all of them within the same 12 seconds, but you cannot send from the same one 2 times in the same 12 seconds. Same thing if you have hotkeys with miners and you want to move the tau that you've earned to your cold key. You have to do that in a sequence. There are automatic scripts to do that, but yeah, it takes a little bit of time to unstake from all your hotkeys from that reason. On most subnets, an interval is 350 blocks. So that's about 72 minutes. Each block you can register up to 3 miners on a single subnet. So we can see what usually happens here is that price dips, and then people register 3 miners right away, and then price increases. Then after a while, about 72 minutes, price drops again, and people register. So that's why we see these price drops and increases. It's because people register when the prices are low, then it goes up, then it goes down, people register again. And when it goes up, people of course don't register, which causes the price to drop. Let me just check if you have any questions. No, not yet. Please add any questions you might have, because I'm curious to hear what you find interesting to hear about or get explanations of. So about distribution. On each network, 42% of newly emitted tau goes to the validators. So they get rewarded for doing proper validation and having high v-trust. And then 42% goes to miners, which incentivizes them to do whatever service that the network asks for them. Then 18% goes to the subnet owner. In the case of this subnet, subnet 23, the task of the miners is to generate images using specified models. So basically, validators send a text prompt to them and ask them generate an image about a dog wearing a hat. Then the miner has to generate that image and send it back, and they get scored on how fast they do it, and also the validator checks that they use the correct model to generate the image. So that way we can incentivize the miners to run the specific models that we want them to run. In this case, it's 3 models. It's Anime v3, SDXL, and Realistic Vision. I think I will just take a moment and share a demo of how the network front, how the front end looks for the network that you can interact with and try it out yourself. It's actually released today. So basically how it works is that to the left here, you can actually try out the network yourself. You select a model, and for some reason I can't see my mouse. You select the model. There are currently 3 models on network, as you can see: SDXL, Turbo, Realistic Vision, and V3. And they are roughly equally distributed because they all get the same amount of emission. And if there's too many of one, they will get less emission, and the ones that there are fewer of will get more emission. So that balances itself out. I'm just gonna go ahead and
If I may interrupt, is that balancing mechanism, it's baked into this, or is it something that is done manually?
So it's baked into it. The way it works is basically that validators, they have 3 pools of emission. 34% go to Enemy V3, 33% go to Realistic Vision, and 33% goes to SDXL Turbo. So if there are 100 miners running a specific model, they will get 100 of 33% of the total emission. But if it's only 10 miners, they will get 1/10 of 33%, so they will get 10 times more emission. And this is because every validator is running the same GitHub repository, where we have decided that this should be the emission distribution for the miners. On this subnet 23, the updates are every Tuesday. So every time there's an update, the validator updates at the same time, and that way we can switch out models, and we still have a nice consensus. Does that answer your question?
It does indeed. Thank you.
Perfect. Yeah, so this is just an example of what you can do with the network. You can you enter a prompt and a negative prompt, and this is sent off to a random miner, and it gives a response. In this time, it was 6.7 seconds. The faster they are, the better score they get. Right now, it just picks a random UID of that specific model. But if you have a key, you can also specify what miner you want, because each miner is running a model. When it comes to cold key, you can have an infinite number of hotkeys connected to a cold key. So sometimes you will see a lot of hotkeys being owned by one cold key. Like in this case, we can see that this cold key owns 27 hotkeys that are 27 miners on the network. And that means that, it's probably the same person that has these 27, the same person has these 16 and these 14 and so on. You can see that there are a lot that has only one. Sometimes it can be useful to look at this to see how distributed the network is, and if someone is doing a good job and have many miners, that could be fine. But on some subnets, it could also be a sign that something is not working as it should. But this overall looks pretty good. However, there's nothing that prevents anybody from creating multiple cold keys. So theoretically, the same person could own all of these cold keys and just have just chosen to structure it that way. So to start mining, you have to look at any specific subnet you might be interested in joining, because the rules are different. If you take this subnet 23, for example, you probably need GPU and be good at optimizing image inference, because you just want to as cheaply and quickly generate images given a specific model. On text prompting, it's more important to have good large language models development skills, since the goal there is to create a smart model as possible for the specified tasks. And they have a specific algorithm they use to evaluate models. So you need to look into that and like try to develop a good model as good as possible. If you're into machine translation, you can use this network. This one is for data scraping, so you probably don't need any GPUs there. You probably want high bandwidth, and I think it's a Twitter API you need as well. Yeah, so there's a little bit of everything, and it varies a lot what the requirements are on these subnets. However, most of them share the same hyperparameters, meaning that they have 256 miners and 72 minutes interval. Yeah, it's just the way that it's scored that is different between these subnets. So I hope that's a clear introduction covering most of the basis of Bittensor, and from now on I think we'll just take questions. Yeah, if something was unclear or something we can clarify. And thank you everyone for joining. I'm very happy to see a lot of faces, some new, some recognized. How do validators decide what is a good generation is a question we get. That depends on the subnet. So each subnet has unique code for determining what good generation is. So some subnets, they might use an AI that looks at the generation and compares the different generations made by different miners and basically score them and says, oh, this is better than this. There are lots of AI models that are trained for that specific task. Oftentimes an ensemble can be used for it. In other cases, like in the case of subnet 23 that we looked at, the models that miners should run has been given. So validators, it's enough that they check about 1% of the time that the image generated is using the correct model. So they can basically compare, is this image identical to the one we would expect with these settings from this model? And if it is, they give a good score. If it's not, they give a bad score. And also there's the, on subnet 23, there's also a time penalty. So if it's very slow, you will also get a lower score, but if it's very fast, you will get a better score. On other subnets, it can be a combination of AI with speed, or they can check that a minimum requirement is fulfilled, for example, that like, oh, is this at least this good quality, or is it at least this fast, or is this like node running correctly, storing the data correctly? So it's different from network to network, what is good, but it's the same that validators run a repository provided by the subnet owner, and that's how the miners are evaluated. So all validators set weights for all miners, and then there's the consensus of all validators that decides the final incentive and rankings of the models of the miners. Bittensor Blaze says, does Taustat link to the incentive algorithm code? No, because all the subnets have different incentive algorithms. I assume you're meaning like the code that the validators are running, because that is different from network to network. However, what is the same is that the consensus of the validators votes, that's the same mechanism. And that basically says that the more stake you have and the more similar to the average weights you set, the more impact you should have on the incentive. So if you have a big validator, you will have a lot of impact on how much incentive each miner gets. So if you run a faulty script, that might have a big effect. But if you run a correct script, that should also like kind of secure the network more. I hope that answers the question. If not, feel free to ask again. Okay, he followed up with, if I wanted to try and become a validator, I should know what my score is. Where would I find it? To become a validator, first of all, you need a lot of tau. So it's not really feasible for most people because you need minimum 4,000 tau, but it's probably not worth it unless you have something like, I don't know, 20,000 or 30,000 tau, because you need to receive good emission, you need to be active on all 32 subnets. But if you would know what your score is, I'm not sure exactly which score you're referring to. But for validators, what matters is V-trust. The higher V-trust you get, the more emission you get. But you can also see the weights you set on the chain. It's it's basically a tensor containing all the UIDs and the incentive you suggest they should set. I don't think there's any easy way to see that, but you can download the metagraph and then manually check the weights that your validator or any other validator has set. And that will basically be a tensor on the subnet for that specific subnet that says, oh, this UID should get this score, this should get that score. You can't see that directly on Taustat, sadly. You can only see the like consensus there, which is like the final one that affects how much emission miners get. The Bittensor library, it supports downloading the metagraph, and from there you can see all the information on any of the subnets. I said validator, but I think I meant miner. So if you want to know your score, you should look at incentive, because the incentive is basically how good you are doing. If you have high incentive, that's very good. If you're low incentive, that's bad, and you might get kicked out. Yeah, incentive is what you're looking for. Thank you, MrNiche, for all the info. Is there code that runs to check good generations on subnet 23? Where is that viewable? Not sure I understand the question. Check good generations. If we go to the generator, first of all, what we can see is the scores for UIDs. So if you know like a specific miner, you know like, oh, I have UID 110. Then you can check the score and see like, oh, my mean score is 0.89. That's a very good score. By the way, the perfect score would be 1. But that would mean that you always reply completely instantly, which you can't do. So 0.89, that's still pretty fast, and you make good generations. This one is 90.7. And yeah, it means that like, oh yeah, you have pretty good times. These two, they're something isn't working for them as it should. For example, they might be running the wrong model or not responding or something. I don't know, but yeah. So here we can see like how your miner has performed on average. However, this is only for subnet 23. Most subnet don't provide this sort of data. Most subnets, all you have to go off is the incentive. If you have a secret key here, you can specify a UID and actually test it out and see if you get the images and it's working. But it's not open to the public, so you need a key to test it. But as I said, this is only for subnet 23. Different subnetwork have different rules. Hope that answers that question. If not, please ask again. How are validators checking good generations? As I said, it varies. On subnet 23, they compare the image with one generated by their own model or a model provided by the subnet owner. it's up to them, and then compares if the output is correct. If it's correct, then it gets a 1, and if it's not correct, it gets a -1, I believe, and it gets a 0 if it doesn't respond at all. Also, there's a time penalty on subnet 23. Most don't have time penalty. Most subnets don't have it, yeah, so it basically gives you a better score the faster you respond. So on subnet 23, it's not about quality. Either you run the correct model or you don't. But on subnet 1, for example, they have AI models. They have sophisticated AI models that actually rates your answer. So you get a score that is AI generated to measure the quality. I don't think they have time penalty on subnet 1, but I could be wrong about that. So that then it's all. I think it's only about having high quality text. Also, the default timeout on most subnets is 12 seconds, meaning that miners has to respond in 12 seconds, or the request will be timed out, and they will get basically 0 score for that request. Yeah, I hope that answers the question. That's for subnet 23 specifically. Bittensor Blaze says, so the assumption is that the subnet owner has the right answer. How would you improve upon that for 23? So first, let me say that the subnets are like anyone can register a subnet. I maybe should have said that before. It costs at least 100 tau, but you can get it back if it's deregistered. And whenever someone registers a new subnet, the subnet with the least emission is deregistered. So that means that basically anyone with a good idea, they can register a subnet, and if it's good, validators will give them emission, otherwise it will deregister. So for subnet 23, of course, the subnet owners for every subnet, they make the algorithms that validators use. Of course, they can't actually force validators to use their code, but since validators want to stay in consensus, have high V trust, they're gonna run the code that the subnet owner provides. And how do you know that the subnet owner has good code that can't be exploited and yeah, that is working well? Well, it's a little bit tricky, but hopefully you can test how good is the network to use. Is there like also if there are any real world applications on the network, that's a very good sign that it works well. And if it does, then well, the subnet owner did something right, at least. So it sounds Bittensor Blaze says, so it sounds to me like image generation has work to do to create an incentive mechanism that actually incentivizes better image generation. Both yes and no. For subnet 23, we're actually planning to create open categories where miners can pick any model they want, and then they there's an AI model or probably a combination of multiple AI models that scores the quality of the image. It will check like, oh, how closely does it follow the prompt? How visually appealing is it? And maybe some other factor, and it would combine this into a score, so miners can actively improve the models. But also having the current structure where the miners are told what image models to run can also be very useful, because it makes it very more dependable. You know that you're gonna get an image generated by this model. That means you can probably use it in apps and such. Of course, it has to be reliably tested, but at least in theory, it's should be easier than to guarantee that it works as expected. With these open categories, it's easier for example, for a miner to over-optimize, they might generate images that scores very, very well, but don't look as good. It's called overfitting in machine learning terms. You do something that's very good for that specific tasks, but overall the image might not look good, and yeah, might not be also consistent with the output style and such. Yeah, hopefully we'll get a combination of both. So you either can pick like, oh, I want this model that I know what it is, which will always be the same, or you can pick like an open category where it like determines for you which model is the best. That sounds good, he says. So incentive mechanisms are not immutable on the blockchain. No, they're not. Basically, for each subnet, there's a GitHub repository with a repository owner, and they push updates frequently. So they can change the incentive, like the scoring mechanism, on a regular basis, and it's not on the blockchain. As long as validators wants to run the code, that is all it takes. FYI, I have a master's degree in AI software engineering. I'm familiar with AI, just learning about Bittensor. Cool. Welcome. We appreciate AI people in the community. It's like talent is what will make this fly even higher. And also I appreciate all the questions. No question is too much of a beginner question for today's session. We're focusing on the very basics for today. Yeah, I don't hear any specific questions right now. So if people have it, you can add it. Also, if you just want me to talk about a specific area, like you want to talk about the top validators, or you want to talk about the specific subnet, you want to talk about registrations or the consensus mechanism, you can just drop it in the chat and we will cover that. We can. You're curious about the storage subnet. I think there are currently 2 storage subnet actually active. It's number 7 and number 21. So the cool thing is that since anyone can create a subnet, it naturally makes it so that there's like an element of competition forcing subnets to get better, otherwise it will be outcompeted. So currently we have these 2 subnetworks, and I'm not entirely sure about the detailed mechanisms, but basically validation is done by ensuring that the miners stores the files properly. And if they don't, they will get penalized, and if they do, they will get rewarded for that. I think both of them also gives higher rewards the more data you store and the more reliable you are. The exact implementations, though, I think vary quite a lot between the 2 subnets. So a newbie question, that's perfect for today. If I wanted to run a miner node, what is a basic system I could use? Yes, to run a miner, you first need to pick a subnet, and there are roughly 32. There are 32 in total, but not all of them are active. I would actually recommend people starting with something that has fairly low emission, and it should be fairly new, because if it's a lower emission, it's probably less competition, so it can be easier to start with. So this one, 31, for example, I think is that the healthcare one? It's fairly new and it's fairly low emission. That probably makes it an easier subnet to start with than some of these with higher emission that has been around for a longer time. Then what you would do is two things. First, you would find the repository to see what are they looking for the miners to do. I can go and try to find the repository so we can actually look at how you would go about this. We have the link here to the healthcare subnet. They basically describe here how it works, competition on and rewards, and then also how to install it. So if you looked into this and you think like, oh, this subnet, it looks good, I understand what it does, and I understand how to do a good job as a miner. What you would do is you would create a cold key and a hot key, get some tau, and then register a miner on the network. We can see what this one requires. Basically, you would run the installation script, install everything, install Opentensor, and then here, yeah, they say exactly how to start the miner. On this subnet, we can see here that they do require you to have GPUs. So you might want to use RunPod or something, or Vast. I think those are the two most popular. To get an instance with, in this case, 2 GPUs, it looks like. And yeah, also you need to make sure you have some open ports. So you start it, you specify the wallet name and the hotkey. And yeah, that should start the miner. But then you also have to register on the subnet. Also, with these lower emission subnets, it's also cheaper to register. So that is also easier to start with. You don't have to spend like $500 to try it out. In this case, you can spend $100 to get a miner. Then you have 24-hour immunity, and hopefully your miner survives and goes on to produce incentive for a long time. One thing I forgot to mention is that three miners are recycled every 72 minutes. That's the maximum, and on average per day it's 30 miners per day that are recycled. So it's about 1/7 of all miners recycled per 24 hours. I hope that was helpful. I have another comment here that says, so when it comes to image gen, I see an increased popularity when it comes to text in the image, but the model is actually not designed for text in the image. Is there a way to make this text more detailed using such a model? Well, I think it's up to the subnet owners to either incentivize like miners use specific models made for text, or have an open category where they send lots of like requests to add text to image and somehow score how clear and detailed these texts are. None of the current subnets has this as has been working on this to my knowledge, but it's possible it will be added in the future. Like, oh, on our subnet we have this model that is great at creating cool texts. I hope that answers the question. Also, to answer the question, I'm not sure if there's any up-to-date tutorial for running a miner, but there is this Tensor Teacher repository. That's a outdated mining tutorial. So this shows how to start mining on on subnet 1, but it's quite outdated. But it talks a little bit about GPUs. It talks about
We've
how to set up
updated.
Subtensor.
We've updated the docs yesterday. We pushed the update. However, I've gone through it, and we will be updating it again so that people can find it clearly, and they don't have to look through the docs to find how to use how to mine with the models.
That is perfect. Would you mind dropping the link in the chat? It's bittensor.com, right? And then there. Yeah, so yeah, I guess you can go on here. Yeah. First, this is for subnet creation, but yeah, basic subnet tutorial. Yeah, that's perfect. You can find everything here then. Everything up to date as well. That's perfect. Thank you for that. Yeah, thank you, Dorian. Do we have any more questions, or you want me to go through this in a way? Pretty straightforward. You install it, you create cold key and then hotkeys. You need to buy some tau or get some tau some way. And I can tell the subtensor, that's basically a node in the network connecting with everyone else's nodes. So you basically get up-to-date data from the chain. So that means that if you want to fetch data or push data to the blockchain, you can use your own subtensor. The foundation has one that is open for usage, but it's more reliable to use your own. Yeah, when you have that up and running, you follow the instructions in the specific subnet repositories. And you find all the subnet repositories most easily by going through the Discord. Each subnet has their own Discord channel. So, yeah.
We will also be in 3 days releasing a directory for subnets that will have all the subnets repos, the description, in a very easily accessible place, and that will be a part of the developer docs as well.
That is awesome. Yeah, that's just what we need. We'll get so much. It will be so much easier to enter Bittensor. It's a fairly complicated, process to get started. So the more docs we have, the better. Did you say RunPod is a good cloud system to start with? I would say RunPod and Vast are the most popular systems to start with if you need GPU, because they have GPUs for a very cheap price. For CPU, I know DigitalOcean and Contabo and AWS are popular options. But yeah, it also depends on the subnet, what you want. If you want GPUs or you just want CPUs or you want something else. Does Google Cloud work? Yes, it works. It works. They both have CPU and GPU servers. Absolutely. Awesome. Unless there are any final questions, we will round off this call, and hope this has been a useful call for you. And the next Teacher Tuesday will be in 2 weeks, so I will see you then. Yep. Thank you, everybody. Bye for now.